Welcome to In 5 Minutes. We take problem on flitched beams. A problem statement is, a flitched beam consists of a wooden joint of 100 mm wide and 200 mm deep and is strengthened by two steel plates of 10 mm thick and 200 mm deep as shown in the figure. So this is the given figure of the section of a composite beam. If the maximum stress in the wooden joint is 7 Newton per mm square, find the corresponding maximum stress attained in the steel. Find also the moment of resistance of the composite section. We have been given the values of Young's modulus for steel and wood as ES is 2 into 10 to the power 5 Newton per mm square and EW is 1 into 10 to the power 4 Newton per mm square. So if we see, this is a composite section of case 1 in which the centroidal axis of each of the section passes through the centroidal axis of the composite section due to symmetry. Now let's write the given data. First, we've been given that the maximum stress in wood is equal to 7 Newton per mm square, and they've given the values of Young's modulus as ES is equal to 2 into 10 to the power 5 Newton per mm square and EW is 1 into 10 to the power 4 Newton per mm square. And in this problem we have been asked to find, first, what is the corresponding maximum value of stress in the steel, that is sigma max of steel. Then second, they have also asked to find out the moment of resistance of the composite section. Now let's solve the problem. Now we see that our composite section is symmetrical about the centroidal axis of the composite section, and we see that the Y max of wood is same as that of Y max of steel. So the extreme layer of both wood and steel are same from neutral axis, and this information we get from the cross section. So Y max of wood is same as that of Y max of steel. So we know for the composite section, at any particular layer, the sigma max of steel is equal to m times the sigma max of wood, where m is a modular ratio and is given as sigma max of steel is equal to Young's modulus of steel upon Young's modulus of wood into sigma max of wood. Now upon substituting these values, we get the sigma max of steel as ES is 2 into 10 to the power 5 Newton per mm square upon EW is 1 into 10 to the power 4 Newton per mm square into sigma max. Maximum stress induced at the extreme layer in the wood is given as 7 Newton per mm square, so 7. So this value comes out to be 140 Newton per mm square. This extreme layer, the stress in wood is 7 Newton per mm square. The stress in steel at the same layer is 140 Newton per mm square.